And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and we're looking at the sun and ionized helium here, 304 angstroms from the Solar Dynamics Observatory, to see a coronal mass ejection propagating as we make the video once again. So it's coming out of sort of the area just north of Sunspot 2822, which is this active region right up here under my pointer. And we'll show you more on that momentarily. First, a view in a different wavelength. Here's 131 angstroms. This is ionized iron, one of the many ionized states of iron, followed by the SDO. And you can see it looks like a fountain coming out right here. You'll see right in this area. I'll let it play through a second time. Right there, you can see the coronal mass ejection beginning to propagate. And let's give you a better idea of where that's coming from and where it's headed to, shall we? As we saw a geomagnetic storm just 2 days ago from a coronal mass ejection. So heading out to Lagrangian point 5, the location of the Stereo A spacecraft, to view the sun from a few weeks behind the Earth, orbitally speaking, and you can see there is a coronal mass ejection propagating. So this is taking its time here. We could watch this play out over a lengthy period of time. There's also the likelihood of a non-Earth facing coronal mass ejection. And for you new viewers out there, Earth, from the perspective of Stereo A here at Lagrangian point 5, is located out in this direction. And again, Lagrange point 5, that's where it's located. There's the data from the Stereo A coronagraph. Here's some more imagery of Sunspot 2823 in 131 angstroms. And we'll also show you Sunspot 2822. Both of these sunspot groups have degraded over the past 24 hours. Some minor flaring visible. And of course, our regular viewers would be well aware that we don't need to see sunspots nor solar flares for coronal mass ejections to happen. Great view of this, and this will be a good display in various wavelengths throughout the day today. Perhaps we'll make another video. So here's the colorized magnetogram, and you can see the slight degradation of Sunspot 2822. That's this smaller one down here, and Sunspot 2823 rather is this one down here. Sunspot 2822 is this one up here. They've both degraded a little bit. There's a little bit of migration of the fields there of this northern one. You can see it's actually backward rotating a little bit there. It's a little bit of migration happening. So here's a chart of the solar system, a diagram of where planets and so forth are located. Keep in mind, it is not to scale. And here's where things will be in 1 week. And if you're up before dawn, you may see Jupiter and Saturn rising ahead of the sun. I like to use in-the-sky for my star charts. And back to solar data, the radio flux is still at only 75 solar flux units. Here's a 1-year chart of the radio flux, the output of the upper solar chromosphere and lower solar corona. The black line's the radio flux, the red line is the sunspot number, and the post-dam AP index, the interplanetary magnetic field, has dropped right back down. So we saw this sudden spike here right around the same time we saw the coronal mass ejection strike the Earth geospace. Post-dam planetary index has dropped back down. So we're not expecting any solar storms or anything like that at the current time. We'll have to wait until more data comes out about the ongoing coronal mass ejection to make any guesses about that. The current NOAA forecast is for nothing special to be happening, And let's move into the realm of seismicity. We're seeing a 7 magnitude earthquake drought, as you can see here on the past 90 days. Global seismic activity level here on volcanodiscovery.com. It's a 7 magnitude earthquake lull, and we may be seeing some foreshocks from that coming in as we speak. So we saw 3 6 magnitude quakes here over the past 24 hours. This one near Honshu, Japan, 9 hours ago. This one almost a full day ago near Panama. And most recently, only 2 hours and 9 minutes ago from when we made the video, a 6.7 off the coast of northern Sumatra, Indonesia. Let's scroll up the list here. Papua New Guinea saw a deep quake. Also Alaska saw a deep quake. Wallis and Futuna saw a deep quake. That was a 5.7 at over 420 kilometers depth. And leave us a comment if you know the deepest hole ever dug by mankind. Do you know anything about the Kola borehole? Leave us a comment. Let us know what you think about the Kola borehole and why there was so much hydrogen at the bottom of it. Also, Colombia saw a deep quake. Again, there's that 6.0 at Japan. May have caused some damage. It's showing up orange on the pager. And just scrolling up the list, another small deep quake at Alaska, a 4.2 deep quake at Chile. And here's this 6.6 at Cinnabang. And we'll just bring this up on the other map here to show you the location of that, the largest quake of the past 24, a 6.6 magnitude. Let's hope it wasn't a foreshock, as that could be in a tsunami generating zone there. That 6.6 magnitude quake. Continuing on to volcanoes, Cinnabung has actually erupted in a spectacular fashion, producing pyroclastic flows and a 40,000-foot plume of ash. It's today's volcanic high point. The volcanic high point is the volcanic ash plume above Cinnabung. What else has been erupting? Well, Sumenosejima, 6,000-foot ash plume there, and again 40,000-foot ash plume above the Indonesian volcano on the Isle of Sumatra, Cinnabung. So, also a phoenix cloud was produced. It's not sure whether the eruption was a volcanian type eruption. But in any case, there's the data. Semeru also in Indonesia on the Isle of East Java, producing a 14,000-foot ash plume. Pacaya in Guatemala exploding, as well as Fuego. They're producing 11,000 and 14,000-foot plumes of volcanic ash, respectively. Sangay in Ecuador, uptick there. It's producing a 20,000-foot volcanic ash plume. Sabancaya exploding as well. Sporadic emissions have produced a 21,000-foot ash plume. And Nevados de Chilean is reminding us through its explosive activity and a 13,000-foot plume of ash not to pole vault the caldera. This public service message brought to you at massive personal risk and expense from smAshomash.com and Smash staff. And let's get back to looking at solar data here. We saw one significant B-class flare here, nothing in the C range. The peak flux of that B-class flare early in the morning today on May 14th occurred at 10 o'clock Universal Time, 10 o'clock Zulu, 10 o'clock Greenwich Mean Time, perhaps. And we don't see any proton strikes either. We show it daily because it's associated with coronal mass ejections. We're also seeing low lows and low highs on the GOES magnetometer here. There you can see the 3-day chart. And these spikes were associated with that large spike in the interplanetary magnetic field, post-dam AP index, by the way. But now we've moved into a regime of low highs and low lows. Anyway, that's the 3-day GOES magnetometer chart, also measured by the GOES 16. Let's take a look at the heliospheric current sheet. Earth is solidly in a south pole-oriented current sheet shown here in red. It's the top view ecliptic plane field plot. A bunch of magnetometer data from Stereo A. That's a terrible A. Stereo A, Stereo B, and ground-based magnetometers at the National Sunspot Observatory. Here's a line of sight ecliptic plane field plot. No major changes happening in the current sheet right now, at least in the earthly portion of it. Here's the line of sight coronal hole plot, and we can see some evolution of the solar fields here. You can see some fields showing up from behind the far side of the sun there, an indication that the solar polar field reversal process is indeed commencing during cycle 25. That's good news, folks. Coronal holes associated with the South Pole also rotating in the Earth-facing zone. We can expect a coronal hole wind stream from those in about 3 days, a little more than 3 days, I would say, probably. They might be weak. They're looking very diffuse. And here's another view of that, and also the current sunspot analysis. So here we're looking at detected coronal holes and sunspot groups. And the coronal hole rotating in there on the east is getting close to the equatorial region there. It's nearly a trans-equatorial coronal hole. Although these aren't super well-defined coronal holes. And you can see the degradation of sunspot 2823 and 2822 on the detected sunspot group's imagery. And the KP index, a measurement of global geomagnetism, currently only at 1. How about a look at the real-time solar wind? It's been pretty uneventful here over the past 24 hours. Current conditions are about 4.5 protons per cubic centimeter as far as the density, solar wind speed, background levels here, 389 kilometers per second. Here's the Geospace Magnetosphere movie that we show daily on the channel. 4 hours of magnetohydrodynamic pressure data according to the Space Weather Modeling Framework. A little bit more normal pressure here. Yesterday we showed in the afternoon a very odd and equalized pressure all around the planet Earth. That has now subsided a bit. Looking a little more normal there. Now looking at ground magnetic perturbations here, we're looking at the polar view. And for you new viewers, most perturbations to Earth's B field occur at the poles. Here's a great visual analysis of that in nanotesla, rather. This is a, we saw a pulse right there. Looks like a global pulse happened. Check it out. What is up with that? Could be some anomalous data, as it's showing a minor pulse there over a large portion of the northern hemisphere. Looks a little anomalous to me. It doesn't really look like legit data. We'll also show the global view. Just before we close out the magnetism section of the daily space weather. Again, and each of these is 4 hours of data, folks. We show it daily because the data is not accessible in the archive yet. We're hoping that comes soon from University of Michigan. And continuing on with the daily space weather video, let's take a look at the electron flux around planet Earth. Here's a diagram of the Van Allen belts. And we're going to take a look at electrons. So these are measured at about 300 kilometers of altitude of the Ionosphere Layer by the GOES-16 satellite. Here's a 1-year chart of the electron flux. And we're back to pretty low levels of electron flux here. Here's a 3-day chart of that. No warnings over the past 3 days, although we nearly reached warning levels there. And that can cause charge-ups of satellites and communications problems when satellites shut down in an event called a CCD bakeout, which is when the charge couple device shuts down to prevent itself from being damaged. We don't see any charging hazards. Here's the forecast model for electron flux. And you can see the observation was a little bit lower than the forecast here, which would be the green box. And we are expecting an uptick. I would agree with Noah on these next couple days, expecting to see higher levels of electron flux. Here's a total electron content forecast. It's the entire air column. It shows you the electron density all the way from your GPS satellite down to your handset. And we've shown some very chaotic and anomalous electron content over the past couple of days. Things are looking a little more normal now. And next, the ionosphere layer. So here's just one slice of the atmosphere, folks, just the ionosphere layer around 300 kilometers of altitude. And you're looking at vibrational frequency. And we've actually changed up this portion of the daily space weather now for you regular viewers. This is now showing 2 days of data at 1 hour per second. It shows a little bit better and more compressed version of what's going on in the ionosphere. It's showing 2 full rotations of planet Earth and the ionospheric pressure associated with those. And we're seeing some anomalies here, some highly charged up regions in the southern hemisphere, surprisingly, despite it being southern hemisphere autumn. Just kind of let this play through here. So give it 1 minute. And in many ways, the ionosphere is the bridge between space and Earth. There are a lot of charged particles up there, and this is how they are vibrating. So here is the latest image from 9 o'clock Universal Time. Things looking fairly normal there. And again, the ionosphere is located, the F layer of the ionosphere is located at about 300 kilometers of altitude. And let's do a meteorology segment. This one will be part of the daily space weather video. So let's get to it. Here are the surface winds of the eastern world. We've got some strong ones off the west coast of India as well as the west coast of Australia, and some turbulent winds down there in the southern Indian Ocean. Here are the jet streams of the eastern world. Some meridional jet stream flow there in the north. And some rather abrupt kinks here over eastern Australia in the south. Here are the jet streams of the western world, a little more coherent on that side of planet Earth. Here are the surface winds. And we see these oddities once again in the North Atlantic, these low wind pressure ridges here. They're really wind troughs, areas of extreme calm winds, which perhaps are relevant meteorological data, just like data about strong winds when they're looking strange. All right, let's continue on here to lightningmaps.org. We use it regularly at Smash News Network, least busted. Name and news. It's your global lightning map. And we see some lightning around Mexico and Central America, as well as Europe. And some strikes coming in as we make the video once again in central Kansas. So we saw a strong-looking storm here near Ellsworth. Hey, Ellsworth, there's thunder rolling in. Hopefully you will not be transported to Oz, and you will remain in Kansas, along with Toto. And here's the NASA GOES lightning map, where you can see that lightning moving there from Nebraska down into Kansas. Continuing on with the U.S. Doppler. Oh, first the pressure maps. Yes. Pressure maps are next, folks. Here's where pressure cells are now. And we'll advance this into the Euro forecast. This is the European forecast for pressure at 1 p.m. tomorrow. Powerful low pressure system there over Nevada, it looks like. And next we'll show the U.S. Doppler radar map. Let's get to it. And there you can see that one concentrated storm there moving to the southeast across into eastern Kansas. Let's see what's going on in the cloud layer. And let me speed that up a little bit. It's a little bit too slow for my liking. Here's the water vapor map, and there's the cloud layer. Once again, the U.S. Doppler radar. Some snow continuing to fall in Wyoming. And once again, there's the water vapor map and the cloud layer. And that's today's meteorology segment. Thanks for tuning in, Twitch viewers. We'll have to say goodbye to you. Bye, Twitch viewers. And let's close out the daily space weather video with our bonus features, starting out with cosmic rays. And we've sort of integrated this into the meteorology section here because cosmic rays are associated with meteorology. Cosmic rays cause clouds to form, especially in the lower troposphere. Anyway, here's the Apatity neutron monitor. You can see a small downtick here over the past 30 days at Apatity. The Barentsburg neutron monitor also showing a small downtick over the past 30 days. Let's go farther south to Greece. Indeed, Athens, Greece. There is a neutron monitor there. And it's a little flatter here over the past 30 days at Athens. Let's go even farther south to Mexico City. A downtick similar to Apatit and Barentsburg there at Mexico City's Cosmic Ray Observatory. And last but not least, we'll look at Oulu, Finland, DOMC, and DOMB Antarctica. So there's Oulu, Finland. Also a downtick over the past 30, DOMC Antarctica. Downtick over the past 30, and DOMB Antarctica. A downtick over the past 30 days. Don't take our word for it. You can monitor them yourself. I like to use the links to Cosmic Ray data site. It's a Russian site. If you're scared to use it, then don't. I don't know what to tell you. But in any case, here are some more bonus features. It's the latest hydrogen alpha imagery from the National Sunspot Observatory. So this one is 6 minutes and 34 seconds old when we made the video, from El Teide, Spain. And if you keep an eye on this area right here, you'll actually see the coronal mass ejection that we talked about earlier in the video propagating. Again, it is likely to be in the Earth-facing vicinity. Could it be fully Earth-facing? We don't know yet. It's too early to tell. Perhaps we'll make another video later about that. Here are the high-resolution intensity and magnetograms of the closest star. You can see Sunspot 2823 has degraded since yesterday, as well as Sunspot 2822. No new regions have formed, although there is some activity down here in the southeast. No sunspot formed there yet, though. And here's the magnetogram of Sunspot 2823, and there's 2822. It looks like it's going to become an alpha-class sunspot, so the likelihood of solar flares has actually dropped. Here's the last 24 hours in 1700 angstroms. Slight degradation there of Sunspot 2823. Here is the last 24 hours of the northern hemisphere, Sunspot 2822. It looks like it's lost its trailing umbra there on the magnetogram. Keep in mind the magnetogram and intensitygram are a little bit later data than these, as this is a dynamic star, and all stars are variable stars. And cheers to our viewers for attempting to understand the physics. You can also see the coronal mass ejection propagating there in the 193 angstroms. And there could actually be two happening. We may see a double pulse come out. We'll let you know later about that as well, as we see some ejecta possibly coming out of both sunspot groups. I'll let it play through a second time. And we'll close out the video today in 131 angstroms. You can see some waves going across the sun. Actually, here's 304 angstroms as well. And I think that's actually the end of the video, folks. We're closing things out at 304 angstroms today. I stand corrected by myself. In any case, thanks for tuning in to the Daily Space Weather. And may that solar wind be at your back.